Alright, so here we go. I'm going to show you a problem from the book, Lesson 4.2. This is number 24. We had talked about this in class a little bit. We have this drawing here with two triangles that are kind of right up against each other, and they have a shared point R. And we have some angles and some sides that are congruent, right? P and T are congruent. The angle Q and S is congruent. The angle P and T is congruent. Okay, and we can then look at some of the givens. Some of these are relisted down here. The angle P and T are congruent. The angle S and Q, I kind of mentioned those already. And then we have TR equals PR. This one right here, that's true because we see those lines, right? And then, but then we have some RP. This one right here equals RQ. I mean, I guess, but it doesn't really tell us that for sure. But it's listing that, so we have to assume it. And then RT is RS right there, and then PQ right here is equal to TS. And I can buy that one because they got the angles are the same, so they should be the same. The ones I don't know about, R2 and RT and RS, you know, maybe it's saying we put a reflection on this triangle and they would be the same. I'm not sure exactly where that comes from, but let's explain the answer in the book. But I want you to remember here, sometimes triangles can be proven in lots of different ways, and we're going to be learning things like side, 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 angle, side, and so on. And another way we could prove this triangle is congruent is by the third angle theorem. And if you remember what that is, it says if two angles are shared or the same or congruent between two different triangles, then the third angle is also congruent. And we see that here. So this triangle over here, triangle PQR, has two angles that are congruent with triangle STR. So this other angle must be congruent, and if all the angles of a triangle are congruent, the triangle is congruent. So keep that in mind as well. There might be an easier way, but I think the book just wants to show you how this works. So if you look down, I've got some arrows drawn in here to try to give you some heads up where all this is coming from. But again, when we write a column proof, we put the givens over here. All this would just get put in there. And then the reason we would say that's what we're given, are the givens. The first thing we could then do is we have all this right up here, and we want to just try to prove this one side here is the one that's kind of problematic, right? So, and this one's not so problematic, the PQ. But this one right here, are they equal to each other? Well, we're going to see. And so we're going to start that process by using something called the symmetrical property. And that says if A equals B, B equals A. So if 3 equals 1 plus 2, then 1 plus 2 equals 3. They're equal to each other. Doesn't matter the order. So we do that here. So we say, first of all, PR is congruent with QR, and then TR is congruent with SR. This comes from PR congruent to QR up here, but it's the other way. Instead of PR, it's RP. Instead of QR, it's RQ. But it doesn't matter what order it is. We can restate it using the symmetrical property. It's the same with these ones. Line TR and SR. They're written the other way up here. Line RT and RS. So we just restate them. The next step then is to go down and see, use this transitive property. And this says if A equals B and B equals C, A equals C as well. So we can substitute. If we know A and B equal to each other and B is equal to something else, well, A must be equal to that as well. So then we can take that. We have TR, which is over here, right? And we say it's congruent with QR, which is a separate thing here. So how we can do that is we know that QR is equal to PR, and then we just follow back up here. Let's see. Follow our arrow. Where am I? Yeah, QR to SR, right? So if we go up here, where is it? QP to TS. Let me look here for a minute. So, and what we're doing here is we're looking for the QR is equal to PR. So we look for PR. Is there one where PR is equal to TR? And there is right there. TR is equal or congruent with PR. Not really, can't say equal, but you know, really it says congruent. So TR is congruent with PR, and since PR is congruent with QR, TR is also congruent with QR. Okay, so that gives us that one. Then we look at the next one. We can also say that using the symmetrical property again, we can restate those, right? So it could also be, we can say it the other way, QR is congruent with TR. We just restate it again the other way, okay? And then we can use this other property here. So in this one, we're just going to use that transitive property again, just like we kind of substituted in QR for SR because they're equal to each other. We're now going to go from QR to TR to QR to SR because TR and SR are congruent. If we follow back up, there's RT and RS. They're written the other way, but that's we can just use the symmetrical property and restate them, right? So then we know that QR is then equal to SR because they're equal to each other up there. Then we can go these last couple steps. We can then say because all this is true, the angle PRQ is congruent with the angle TRS. So if we look at that, this right here, PRQ, this angle right here, and then this angle, and it's congruent with angle TRS right there, and we can say they're congruent based on all these things we looked up here because these sides are equal, as we see here, and and then because that's true, because this angle right here, because that was the only thing we were worried about, this R right here, whether these lengths are the same, and we see that they are, okay, by proving that and using these properties, we then know since this angle here is equal to that angle, and we know that triangle PRQ is congruent with triangle TRS. And that's the definition of congruent triangles. Okay? That's kind of how you do it, and I hope that makes sense to you, and let me know if you have any questions.